All right, so let's look at the last section on chapter 8 here, and this deals with carbon dioxide and global climate. So first of all, we need to talk about the normal situation of the carbon cycle. So carbon works through our environment, constantly being recycled between several things. So photosynthetic organisms are going to capture sunlight and carbon dioxide and water, and they're going to make organic molecules out of that. Okay? And then if that plant is eaten by another animal, or if that animal is eaten by another animal, or that animal is eaten by another animal, and so on, in all the plants, in every animal along that food chain, they are going to respire. So doing cellular respiration, either aerobically or anaerobically. And in doing so, we're going to break down those biomolecules and release carbon dioxide out back into the environment, right? So plants take in that carbon dioxide, and then they are going to respire. As you can see, everybody respires, putting carbon dioxide back into the atmosphere. Okay? So that's one way that carbon dioxide is released. Another is through erosion processes. So some organisms make carbon dioxide, use carbon dioxide in making their shells. So like, clams and mussels, all right? So snails even, right? And so that is mainly calcium carbonate, and that is what chalk is made out of, is calcium carbonate. So that chalk was made from organisms that lived a very, very long time ago, and that got all compressed down when they died, all right? So when they die, especially in a water environment, they sink to the bottom, that stuff gets compressed, but over time, that eventually is going to form limestone. But also what's going to happen is that limestone could be later exposed to the atmosphere, and when it gets exposed to rain, that carbon dioxide can be released back into the atmosphere. So that's another way that carbon gets back into our atmosphere. A third way that carbon can get back into our atmosphere is through combustion. So burning of wood or other fossil fuels. Okay? So with fossil fuels, these are plants and organisms that lived long time ago. They died. They collected on the bottom of the oceans or ponds or whatever, and all that organic material was compressed. And what happens with that over time is that becomes coal and oil. All right? And so when we take the coal and oil out of the ground and we burn it, that puts that carbon dioxide that was stored into the earth millions of years ago back out into the atmosphere. All right, so let's look at the greenhouse effect. So the greenhouse effect is what happens in a normal situation is sunlight is going to hit our earth, and our earth is going to absorb that energy, whether it's infrared radiation, visible light, ultraviolet light, absorbs it, and it converts all that into heat, infrared radiation. Now, the infrared radiation will move out of the atmosphere into outer space. All right? What happens here, though, is that greenhouse gases are going to trap that heat in our atmosphere just like the windshields of your car trap the heat in your car. All right? So this warms the atmosphere and the planet. And this overall effect is actually really good because this gives Earth an average temperature of about 59 degrees Fahrenheit. All right? Without it, Earth's temperature would be about 1 degree Fahrenheit. And I doubt we would be here having a nice little class because of that. All right? What a greenhouse gas is any gaseous molecule that has 3 or more atoms is a greenhouse gas. So that includes water vapor, that includes carbon dioxide, that includes methane gas. All right? So the problem here that we have is not that we have a greenhouse effect. The problem that we have is the greenhouse effect running away. All right? So by the start of the industrial age, in the mid-1800s, we started using fossil fuels for energy. And what that did is that has increased the carbon dioxide levels in our atmosphere. All right? All right, and so those have, at this point, have increased by 40%, and this continues to rise. All right, so the more carbon dioxide we have in our atmosphere, the more warming of the air, and thus more warming of the Earth. And since the industrial age, the Earth's global temperature has increased 1.6 degrees Fahrenheit, or 0.9 degrees Celsius, so pretty close to 1. Now, if you think that might not be enough, a whole lot, just to tell you the difference here is whether ice freezes or ice is a liquid is only a 1 degree difference. So it can have major consequences. All right, and so one of those consequences, and we can see here, this is showing raising of carbon dioxide levels over the years. All right, and this is showing this trend of raising carbon dioxide levels over the years. And you can see this kind of staggered effect here. And this is everything to do with most of the land masses are in the northern hemisphere. So when we have summer in the northern hemisphere, carbon dioxide levels go down. We have winter, they go back up. But as you can see, we see an increase in carbon dioxide levels. We also see an increase in temperature. Those things are more than correlated. All right. Here showing another chart showing the same kind of thing here. All right. So, we move here. So what we're seeing, some of the consequences of warming Earth, is that sea levels are going to rise. All right. So water, this is for a few reasons. One is that water expands when it warms. If there's less ice on land and glacier sheets, so we're going to have less ice on Iceland and these other areas, that water needs to go somewhere, goes into the oceans. So sea levels have risen about 6 inches in the past 100 years, and they're continuing to rise. This is showing ice cap melting. We can see this is 79, this is 2016. This has opened up waterways that weren't previously available to us. All right. Another thing we see here is that life zones will shift. Organisms have already shifted northwards. And we can see here, so these numbers are from 68, these are 2015. You can see the darker spots are all more northern than the lighter spots, which all of these things are moving more northern, okay? So all these different organisms, all right? Weather patterns will become more severe. I don't have a picture of this. So if we have more water vapor in the air, we're going to have more energy. We're going to have more severe storms. We're going to have stronger hurricanes. And actually, the Pacific Ocean has actually had more. Weather patterns will also shift northwards. So the patterns that we saw in our area, now we're seeing a little bit higher in latitudes. The last thing is ocean acidification. So I think I've talked about this chemical reaction before, but if you take carbon dioxide with water, it produces carbonic acid, and this will acidify the ocean over time. All right, and this leads to coral bleachings, which is where the corals die. And so this is another unfortunate consequence there. So, you have a nice healthy coral here. You have a lot of organisms that depend upon that ecosystem. When the coral dies, you get a lot fewer organisms in that area.